So we did some experimentation with the triangle inequality theorem. We tested to see which different side lengths of a triangle would work. And now I want to show you the work of some students. So this table was created by a couple of students who just tried a whole bunch of different side lengths. They wanted to see, will this combination make a triangle? So first they tried a side length of 1, a side length of 1, and a side length of 1. This was an equilateral triangle where all of the sides measured 1 centimeter. And that made a triangle. Next, they tried to make a triangle where the side lengths were 1, 1, and 2. That didn't work. Then they tried the side lengths 1, 1, and 3, and that didn't work. And you can see going through the table the different combinations that they tried. The ones that are highlighted in green worked, and the other ones did not. So with a partner, your job is to carefully look at this table. As you look at the table, see what patterns you can find and see if you can figure out, is there a way to predict whether a set of side lengths will make a triangle? Ask yourself that question. Is there a way to see, but without even trying, whether 3 side lengths will make a triangle? Talk with your partner, and also just think as you look at the table, what do you notice? What do you wonder? Teachers, as the students work on this, walk around and check for understanding. Be sure that everybody knows the task that they should be working on and the topic they should be talking about. Set a timer for 2 minutes, and in 2 minutes, we'll come back together and we'll talk about what you guys think. Okay, you've hit play, which means you talked with your partner for 2 minutes and you made some observations. Perhaps you asked some questions. Now it's time to make a conjecture. So we didn't use pasta pieces here. We just used a table that had already been done for us, but we can still make a conjecture. That's what this part of your book asks you to do. To make a conjecture just means to make an educated guess. That's what the word conjecture means. And you can do that because at this point, you know a little bit about triangles and about how to make them. So your job is to write down in your own book what conditions make it possible to form a triangle. What type of side lengths can be used to form a triangle? Make a conjecture about it and write it down. While you write, your teacher is walking around the room and being sure that everybody is writing and getting started. Okay. Good job. If you need a moment longer to think, pause the video. Otherwise, let's go back and visit Sam and Sarah. Earlier, we had a little bit of a debate in our class about who in this scenario was right. We said, is Sam right? Is Sarah right? Are there any combinations of numbers that wouldn't make a triangle? What do you think now? After exploring different side lengths with our table, we now know that in this debate, Sam was correct. There are some combinations that will not work. To disprove a statement, you only need one counterexample. In our table, we have a lot of rows that say no. Those are all counterexamples. Those are all pieces of evidence that we could use to prove that Sarah's wrong. We have demonstrated more than one time that there are some combinations out there that just won't make a triangle. And so that means that in this case, Sam was right. Let's explore a little bit further. You've already made some conjectures about when 3 side lengths will form a triangle. In this activity, you're going to use patty paper to explore how many triangles you can make with 3 side lengths and to see what type of side lengths work, which ones don't.